Hello, stat students. Today we are going to begin Chapter 3 notes, and Chapter 3 is all about the relationship between quantitative variables. The chapter is called Describing Relationships. When we're talking about quantitative variables and we want to know if there's a relationship between them, we refer to that as association. Now, that does not mean that there's a cause and effect, but just a relationship between two quantitative variables. Let's begin with some vocabulary. A response variable measures the outcome of a study, whereas an explanatory variable may help explain or influence changes in a response variable. Okay, let's look at some examples. Identify the explanatory and response variables in each setting. Number one, how does drinking beer affect the level of alcohol in our blood? The legal limit for drinking in all states is 0.08%. In a study, adult volunteers drank different numbers of cans of beer. 30 minutes later, a police officer measured their blood alcohol levels. So the explanatory variable, the response variable we can get from the pretty much the last statement. So measuring their blood alcohol levels is your outcome. That is your response variable. So blood alcohol level, BAC. And what is causing that? It's the number of cans of beer that's being drunk. And that's your explanatory variable. Okay. Example 2. The National Student Loan Survey provides data on the amount of debt for recent college graduates, their current income, and how stressed they feel about college debt. A sociologist looks at the data with the goal of using amount of debt and income to explain the stress caused by college debt. So I always look at the response variable first, like what is being measured? What is the outcome? So the response variable is the amount of stress. Stress is being measured. And what is causing this stress? It's the amount of debt and income. And lastly, example 3, Julie wants to know if she can predict a student's weight from his or her height because information about height is easier to obtain than information about weight. So if you look at the first sentence, if she can predict a student's weight, so the response variable is weight, and you can predict the weight from a person's height. So height is the explanatory variable. And those are just 3 situations where you can identify the explanatory and response variables. Okay. So in Unit 1, when we looked at categorical variables, we used two-way tables to show the relationship. In Chapter 3, scatter plots show the relationship between two quantitative variables. So that's what we're going to focus on in this chapter. Scatter plots are graphs used to display the relationship between two quantitative variables. Remember, quantitative variables are ones that can be measured and it makes sense to take an average of. Explanatory variables should always be graphed on the x-axis. So here would be the explanatory variable. The response variable should be graphed on the y-axis. Just like in algebra, you had your x variable as your independent variable on the x-axis, and then you had the variable y on the y-axis. Always label your axes, just like you did in the previous chapters. Okay, as far as interpreting and describing scatter plots, just to kind of bring back to what we did last time in the previous chapters. When we were asked to describe distributions, we had to comment on four things. And we did that. We did the shape. We talked about the center, the spread, and the outliers. So we remembered the acronym SOX. When we're asked to interpret scatter plots, there's another acronym. There's lots of acronyms in AP Stats. This one is called DOFS, kind of like diffs, DIFS, but DOFS. So D stands for direction, O stands for outliers, F stands for form, and S stands for strength. Plus, you talk about all of this in context relating to the problem. So let's look at the D, direction. Direction can be one of two things. It can be positive association. This means goes up. And you learned a little bit about this in Algebra 2, if you remember. As the explanatory variable increases, so does the response variable. So the picture would look something like this. So as the explanatory variable increases, so does the response variable. Okay? A negative association, and you can, I guess, kind of think of that as a positive slope. A negative association goes down. As the explanatory variable increases, the response variable decreases. And this would be the picture. So as the variable goes to the right that way, increases explanatory variable, the response variable decreases. All right, and I just have these out of order, and that's fine. Just remember that if you talk about DOFs, you're good to go. Okay, as far as the form goes, it's going to be linear or curved. Well, in this chapter, we're focused on linear association. So you have to take the time to check, or else all that work you've done is for nothing. So is the relationship linear or curved between those two variables? Okay, the third one is strength. How close do the points come to forming a straight line? Or forming a continuous curve? This particular one, strength, uses words such as a strong association, a moderate association, weak. And then the last thing that we mentioned when we're talking about interpreting scatter plots is outliers. Outliers are points that are outside the general pattern of the scatter plot. Usually, they're really far above or below the grouping of points. For instance, if we had a curve like this, and over here, down here is a point, that would be considered an outlier. Now, there is another type of outlier that is known as an influential point, and this lies outside right or left of the grouping of points. So if you had a curve that looked like this, or if you had a scatter plot that looked like this, and you had a point over here, that's side by side, so this would be considered an influential point. Now, you don't need to know too much about it right now. We'll do the math later when we're talking about influential points. Just know that it's a form of an outlier that's more side to side, whereas a general outlier is just above or below, far above or below the grouping of all the other points. All right, for the remainder of this section, we are going to we're going to interpret scatter plots. Can you tell a person's age from a blood test? Analyze the scatter plot. So for this particular one, I'll go ahead and write down the acronym DOFS, so direction. And we'll do each one at a time. So is it negative association or positive? So the way to tell, well, this one kind of has a line drawn in for you. You can always look at the width of this, and you can see this one is a negative association. So this one is not hard to tell. So this is negative association. And in terms of context, you can say as blood measurement, because blood measurement is on the x-axis, it's your explanatory variable, and your y-axis, age in years, is your response variable. So as blood measurement, sorry, increases, age decreases. Go. Now let's look at outliers. No visible outliers or influential points. Things are pretty grouped together. So you'd want to mention that. If you haven't figured it out already, there's a lot of writing in this class, and really can't take a shortcut and give a few words here and there, or you will do poorly in the class. Okay. But then again, you don't want to say too much, because saying too much could mean something bad if you say things that don't need to be said. So it's good to just answer the question at hand and then move on. Okay, as far as form goes, is it linear or curved? Well, this definitely does not look curved to me. So it seems to be a linear pattern. And lastly, there's strength. Words like strong, moderate, weak. Okay. This. So the points are pretty close to that line, but they're not like right there on the line. So I would call it a moderate association. Oops. Well, I don't know what I did, but okay. So how do we summarize this so that we don't have to write this much all the time? So here is a quick summary of everything we wrote, and that's what we'll do for the remainder of the problems. This is a moderate, negative, linear association. That's how we mention all of that. Now notice we still didn't cover outliers in that description, but we did talk about the strength of the form and the direction all right here. Right. Okay, for the next one. Okay, if I were to draw lines here, it kind of tells you the direction that it is. So this particular one, again, is very similar to the first one. So I would call it moderate. But this one, the direction is positive, positive slope. It's definitely linear and not curved. That's just the relationship. So always end with association. Right. Okay, the next one. Ooh, this one is a little harder to tell. Is it positive or is it negative? So the way that I knew that it was negative, although a weak one, is if you look at this trailing 3 points, it kind of shows you that it's more this way than the other direction. So just because of if the points that way, if it was positive, it would be going like that, which is wider, and that just doesn't look right. Right. So this one, it's not very strong. I wouldn't even use moderate because we used moderate for the other two, and you can see a pretty decent association. This would be weak. It's negative, still linear, and that's the relationship. Are these really outliers? No, they're just a few points over there, but they wouldn't be really considered outliers, not too far above or below the cluster of points. Okay, the next one. Um, Hopefully, you see that if you were to sketch something like this, you would see a curved form. So this one, but the points are pretty close together, so I would consider calling this one strong. You can make a case for moderate as well, just you need to explain why you would consider so. Um, it's it's a strong positive curved association. So notice in the word positive, that takes care of the direction, curved takes care of the form, strong takes care of the strength, and there you go. Okay, and then the next one, this one is a little, all right, do we go down first and then up, or do you look at the general pattern of the other points? So here you can see a pretty good curve. Oops, sorry. But then you have something out here. I would call this an outlier because it's above, not really sideways, but it's far above or below any of the other points. However, this is still strong. Okay, so let's write down outlier. It's still positive. I would call it a case for positive because if you look at the outlier, you can say that it could be negative and then going, but it's a positive. That's an outlier. You look at all the other points. It's curved. That's the form. And our last one. Okay. So this particular one, I mean, you can make a case either way. You can make a case. Actually, here's what I would do. So if I drew a line here and here, if you wanted to say that was positive, just take a look at the width. Okay. It's a pretty large width. I'll go ahead and leave those lines on there. Now, if I called it a negative, oops, it's definitely narrower. I mean, I missed a point over there. So I would make it a better case as it being negative, but again, you can go either way. It's definitely weak. Is it curved or linear? There's really no curve. I mean, I don't see a case for a curve, so it's linear. Here, I'll put a question mark because it can be a case either way. Right. Now I'm gonna go back and erase these lines so we can see something a little bit better. So if you look over here, this point isn't really above or below the other points, but it is far off side by side. So this could be a possible influential point. So just to recap, section 3.1a was interpreting scatter plots, describing it accurately, and just knowing the direction, the form, the strength, and whether there's outliers present in a scatter plot. And these are the notes for 3.1b. Have a great day, stat students.